question. Where'd you get the gas pressure from in the first place, Zanick?
The force can cause air to compress, to have pressure, and this is observable in all other areas of the Earth. I don't know where you've been, but you can see it in a car. You can see it on an airplane.
Really? Show it. Show it.
Yes. You can actually
show it. I want to see gravity. Show us a picture of gravity.
Drop something. Drop an object.
That's not a picture of gravity.
Wow, Neil deGrasse Tyson.
Yeah, Zanick, that's a video.
Do you have scientific evidence of gravity?
You want a picture of gravity? Why do you want a picture of gravity? That's like
no, let's go with scientific evidence of gravity. Do you have that?
Yes.
You do. Nathan?
Yes. Yeah, okay.
Well,
we haven't done this in a while.
We ready?
Yeah,
1 second.
ready whenever you are. You're not sharing yet.
Yeah, we have a 1 kilogram mass. We drop it. It accelerates. 9.8 meters per second squared.
Yeah, I don't really care about that. We're going with you said you had scientific evidence of gravity. All right? That's what you said. Everyone heard it.
We have an observation.
I don't care. Hold on.
We have an observation, and through experimentation, we prove.
Okay, now natural phenomena observed, please.
1 kilogram mass falls at 9.8 meters per second squared, regardless of elevation or altitude.
That doesn't mean it's gravity.
What is it?
1 kilogram. 1 second. 1 second. 1 kilogram of mass falls.
Hold on, let's gain control again. Look, this is a very. Everybody else, be quiet. This is a very segmented stage process. It's just one question at a time. So if our answer to natural phenomena being observed by Zanick, 1 kilogram of mass falls at 9.8 meters per second. Correct, Zanick?
Correct.
Thank you. Go ahead, John.
Kilogram of mass falls at... Okay, we could just take this whole thing, no problem. That's your dependent variable. You understand that, right?
Correct.
Okay.
And you're going back to the kindergarten scientific.
What's the independent variable? Okay. What's the cause of the 1 kilogram of mass falls at 9.8 meters per second squared?
Independent variable?
Yep.
Distance above the ground.
Distance above ground. So, distance above ground causes 1 kilogram. No, it's not. No, you just gave me the independent and dependent variable.
Hold on,
sorry.
What's the muttering? I didn't hear what he said. What did you say, Zanick? Please repeat yourself.
Words. Ground's not causing it. The distance will cause the different speeds. The distance to the ground will cause the different speeds to be achieved. We're talking about something dropped and achieving an acceleration. And acceleration is the what? Change in velocity.
Does not
right?
cause.
Second derivative of distance with respect to time. That's acceleration. We're trying to show that objects accelerate when dropped. That's the scientific phenomenon. That's the observation. We're looking at experimentation.
Distance above ground causes 1 kilogram of mass to fall at 9.8 meters per second squared. We got it.
The distance to the ground.
Yeah, he put distance. Distance. It's down there. We've got it. I promise, Zanick. I know you can't see it because we're not live streaming at the moment, but I promise he's written it down exactly as you said it.
Height, distance can be an independent variable. Yes.
Oh, it can.
Hold on.
Sure.
Okay, sorry.
You go ahead, John. Sorry, I'm just stealing your thunder. Sorry.
No, that's okay. He said that height or distance can be an independent variable. Really? Remember, viable independent variables must satisfy 3 criterion. It's your presumed cause. Number 2, the researcher must be able to vary and manipulate it. And number 3, the independent variable must demonstrably exist before you use it in an experiment. All 3 criteria.
Zanick, do you agree or disagree?
I wasn't done yet. I wasn't done yet. Be patient. All 3 criterion must be satisfied, not just one. Height, depth, width, length distances and time are not viable independent variables. Here's some examples. Number one, the submarine was crushed at a depth of 10,000 feet. Did depth cause the sub to implode, or was it pressure? Number two, the gentleman was so obese he measured 1 meter wide. Did width cause obesity, or was it laziness combined with excessive caloric intake? Over the course of the night, the sun suddenly appeared above the horizon. Did time cause the sun appear above the horizon? Does time cause the differences of scores between the first and third quarters? So you see how silly these are? Height is not an independent variable. This independent variable right here in your hypothesis,
John, we have to know
is non-sequitur.
What's going on?
None of those
Zanick?
scenarios with height or anything actually.
What triggered that?
Be
What triggered
quiet.
that? Everyone be quiet. What's going on? He's nearly done. It's like 10 more seconds, right?
Yep. This is non sequitur on its face. Thank you.
Thank you.
All right, Zanick, just agree or disagree with what John has just said.
Well, I disagree. Of
You're
course
the
I
one to
disagree.
talk.
I've lowered your train wreck off the screen,
Yeah, you
Zanick,
can
for the audience's
raise-
benefit,
raise
which is
the
really
height
who I'm talking to here, with
of
Zanick
the
talking over me.
experiment
But
and
I've
see
lowered it
if
because
the object is
distance
continuing to
doesn't
accelerate.
cause things,
That's what
and
we're
in
trying
your
to prove.
case,
The
height
object
was
accelerates
part of.
exponentially with height.
He's just talking
That's
through
the
every bloody
experiment.
word.
I can't hear you, Nathan.
Yeah,
He
you can't
probably
because
can't hear you when he's talking.
he's just rumpusing the living crap out of me because I'm
He's
summarising the
lost his mind.
demolition of his assertion that the height is an independent variable. It isn't.
In this test, in this experiment, it is.
In this experiment. No, this is definitely not an experiment. It's a train wreck.
It's an experiment. We're
So
trying to see
why?
the
No.
object.
So why can't
I'll say it
height be an
again,
independent
you-
variable?
Dumbo.
Is
right.
it because it's not a physical? It's not a material. Again,
Yeah, height isn't incorrect. He's just
And-
but that is the reason,
and
right?
more
Because it is
importantly-
like an aspect.
More
It's not
importantly,
a
one
physical
second.
thing.
More importantly, this was a proof of gravity. Where's gravity in here?
Oh God.
Oh yeah, I forgot to mention that. So not
There
I
you
was
go.
going to say, but I didn't want to interrupt you. But yeah, so not gravity then.
Right. I don't think they can test the existence of the acceleration. I think they're wanting to know what the cause of it is, and if there's a scientific experiment that can show that
I see. but-
gravity,
what?
like what we quote unquote call gravity, is the cause behind
Yeah.
the acceleration. Not
Yeah,
just
they want the
that
cause
they're-
to be
Density.
gravity. But when we asked him for the cause,
so
the
then-
cause that he
We can just
gave
have the experiment be drop,
was the
drop
distance
something,
above the
let go of
ground.
an object.
That's what he gave, and now he's rumpusing that train wreck being highlighted. His
Emerald.
cause was not gravity. I was.
I don't think that would work, Zanick, because both the argument of relative density and the argument of gravity would both produce an acceleration. So just saying there's an acceleration
No.
doesn't really narrow down the cause.
No,
to what we
relative
consider-
density gives an actual causal
gravity.
relation to the change.
No,
That's the difference.
relative density disequilibrium.
That's right,
Relative
Nathan.
density wouldn't cause acceleration.
Relative density disequilibrium definitely causes
Well,
acceleration.
what causes
Oh
the
yes.
force then? What causes the force? Why is there's something?
No,
accelerating,
not
why
what
is
causes
it-
the force.
Relative
Zanick.
density disequilibrium. That's what
causes the disequilibrium. See, when you say pick up a weight in your train wreck on screen right now, yeah, you're causing the disequilibrium. So when you say what causes the force, obviously you're dancing past what pushed it into disequilibrium in the first place. In this case, you picking the damn thing up.
You lifted it. You lifted it. You lifted the object.
Yeah, there's your cause.
You gave it energy. You gave it
There's
energy.
your cause,
That energy-
sunshine. No science needed.
that's only-
You picked it up.
That's,
Science is definitely
Nathan, that's
needed.
only
Believe me,
if
you
you're
need
gonna
some science.
Sure,
build
okay.
like a
Yeah, that makes
chain
sense.
of
You're the one
forces
who
and
causes it to
everything.
increase in energy,
Right?
but then what causes it to decrease in energy again?
You letting it go?
No.
Look, that's
Distance.
hypothetical structuring. It's not
Oh yeah, my
relevant to
bad.
the scientific
Distance. Yeah,
method.
Zanick. Yeah, distance caused that shit
As,
to
no,
happen.
as it's been let go, what continues to act on it to act on that accelerate to cause the acceleration? You let it
That's-
go.
It's
once-
density.
theoretical
It's density
framework.
relative to the
No, it's
medium.
not relevant.
It's
Once you let
density
go of it-
relative
once you let
to
go of it,
its.
it
Oh, he's going to rumpus the crap out of it because it's the answer to his question. It's density relative to its medium.
That's a force. That's not a force.
No, it's not a force. That's right. Yeah, Fundy, welcome to Flat Earth. The lack of gravity is only in your future, my friend.
Gravity's not a force, even in your fairy tale.
Yeah.
It's about the differential
Same letting
between the
go.
densities. And the higher the differential, the higher the force that will manifest from that.
Let's take a look at that. You say gravity is a force? Well, it's not. Number one, it's not scientific, right?
Yes, it is. I said gravity causes a force. There is a
so
force.
It's not. Oh, now it causes. Remember, Zanick, this was about a month ago, where you were challenged to bring a citation or evidence of that claim that gravity causes a force, and you couldn't do it. Now you're just bringing it right back up again. You're going to piss it back in our faces.
I gave you one and then talked to more physicists about
it.
No,
you didn't.
No, you zidn't. Come on, Sally. Don't be a liar. Don't be that guy.
Hold on, I'll post it again.
You conceded it. We'll have to dig it out and edit it together. Come on, don't be that guy. Don't lie.
Letting go is not a force. Letting go of something is not a force.
Don't start weaseling around telling us what's not forces, right?
Right. Are we going to take a look at this, Nathan?
The train wreck.
Don't forget, temperature is a force.
Hold on, David. We're going to take a look at gravity is not a force.
Yeah,
that's a ridiculous argument.
Yeah, I've got you back up, QE. You're back up on screen. I just tied you up.
Hey, I appreciate that.
Find me one definition of temperature that includes the word force.
We're not on temperature, Emerald. We're on gravity is not a force.
Order. Right, go ahead, John.
So, as everyone has seen this before, we're going to go through this. I'm loving this. So, as everyone's seen this before for about, I don't know, I've had this citation for a long time. Let's go through them. We'll start off with George Musser. Einstein created his general theory of relativity, which provides our modern understanding of gravity, with the express purpose of expunging non-locality from physics. Isaac Newton's gravity acted at a distance as if by magic, and general relativity snapped the wand in two by showing that the curvature of space-time and not an invisible force gives rise to gravitational attraction. That's number one. From Caltech, Einstein came up with the theory of general relativity in 1915, the prototype of all modern gravitational theories. Its crucial ingredient now, involving a colossal intellectual jump, is the concept of gravitation not as a force, but as a manifestation of the curvature of spacetime. Brian Cox, there isn't really a force of gravity at all. Georgie friggin' Musser again. Gravity is not a force, but you can think of it as a force. From Wiki, their alma mater. Gravity is most accurately described by the general theory of relativity proposed by Albert Einstein in 1915, which describes gravity not as a force. Universe Today and general relativity, gravity is not a force between masses. Strictly speaking, gravity not as a force. From phys.org, according to this theory, gravity is not a force. From New Scientist, so although the Earth appears to be pulled towards the sun by gravity, there is no such force. From Phys Libretext, the answer is that gravitation is not a force between two objects. From the hypertext physics, gravity isn't a force. From Joylyn Bloomfield. From Cornell.
How they know how it's all not a force, but there seems to be very little description left as to what it actually is.
Not a force. Causes a force. You've missed.
Yeah, we know it's not a force, just like we know the Earth is not a ball. But
just a couple more.
Just a couple more.
Be patient.
Zanick didn't claim that gravity was a force, so I don't.
Yeah, he did.
Yeah, he did.
He said it.
So, some Joylyn Bloomfield, PhD physics from Cornell. So, to summarize, general relativity says that matter bends space-time, and the effect of that bending of space-time is to create a generalized kind of force that acts on objects. However, it isn't a force. Did you get this part? As such that acts on the object, but rather just the object following its geodesic path through space-time. And that little statement right here actually pummels Newtonian laws of motion. This one right here. If
No,
we want to
actually,
get to
it
that, we
adds
can get
to
down
it.
to that.
Please,
1 second.
all we've established so far is that gravity is a pseudo thing. It is a
Yes.
sort of
Hasn't
thing,
done yet.
and
I think
that
what
it's
he's
a
trying to
purely a thing that can only be found in the conceptual medium. I love this.
Yeah,
Just
gravity is
nothing.
not a force.
None
I
of
thought
the
that was
things
clear.
dispel any of the other things. It's all a bunch of stories.
It wasn't done yet. One more. From Wiki, their alma mater, the standard model of particle physics is the theory that describing 3 of the 4 known fundamental forces, the electromagnetic, weak, strong, and what's it say? Not including the gravitational force. Why doesn't it include it here in the
Because it's not a
universe?
force.
Why doesn't it include that here?
Not a force.
I'm done.